So today's lesson is about subtraction in equivalent expressions. So we've got a number of expressions here, and we just have to write expressions that are equal to them, but use only addition. So we pretty much only need to, remember the rule that talks about how subtraction is the same thing as adding a negative number. Okay, so if that's all that we have to do, we know that we just have to take a look at our two subtractions here and change that. So I'm adding -9, and then this stays the same, and then I'm adding -7. Means exact same thing. Next one, same thing. I've got two subtracting two different terms. So I'll take 4x. I'm going to add -7y. I'm going to add -5z. Plus 6 stays the same. Last one, I've got all subtraction and negatives. Now obviously I don't need to do anything to the first term because it's simply a negative, which we know is the same as subtracting the positive, but we don't need to do that because it's in the front. And then we add -8y, and then we add -4, and then we add -8/7 z. Okay, next we're going to be using the distributive property to write an expression that is equivalent or equal to each expression. And they suggest, of course, using the boxes to help organize our work, which I know for a lot of you has been very helpful. So I am going to, in fact, set them up like that. So we remember we've got 3 terms here, so I'm going to make 3 boxes side by side. And I know that the 9 goes on the outside here, and the parentheses go up top. So I've got 4x sitting on top of the first box, -3y, don't forget that, and then -2/3. And now I'm going to multiply each of them by the 9. So I've got 9 times 4x. Well, 9 times 4 is 36. Nothing really happens to x. 9 times -3y. A positive times a negative is a negative. 9 times 3 is 27. Nothing happens to the y. 9 times -2/3. Well, I'm going to take this off to the side here just a moment because I'm going to remind you about when we're multiplying fractions, right? Top with the top and the bottom with the bottom. That would give us 9 times 2 is 18. 1 times 3 is 3. And that tiny little 3 is too little to hold up that big giant 18. And 18 divided by 3, of course, is 6. And I know that a positive times a negative is always a negative. So when I rewrite this first problem, I'm going to end up with 36x minus 27y, plus 2. Oh, sorry, plus 6. I was looking at the 2/3. Okay, first one's done. Next, I've got 3 terms again, so I'm going to make myself 3 boxes. Remember the number on the outside, which in this case is -2, is on the outside of the box. And then the rest of the terms sit on top of my boxes, so -6x, 3y, and -1. And I can, it does say positive and plus. I can put it there or not, because when there's no sign there, of course, it means positive. So I've got 2 times 6x, or -2 times -6x. Negative times a negative is a positive. 2 times 6 is 12. Bring the x down. A negative times a positive for the next one is a negative. 3 times 2 is 6. Bring that y right down. Negative 2 times negative 1. Well, negative times negative is a positive, and 2 times 1 is 2. So my answer is going to be everything inside that box. Positive 12x. I don't really need the positive, so I'm going to write 12x plus 6y. Not plus. That's when I glance at it real quick. Sorry. That is minus. Didn't mean to confuse you. Minus 6y plus 2. Okay. Next one. Same process again. Well, that's not going to be big enough. Okay, so on the outside I've got 1/5. On top each term I've got 20y minus 4x or negative 4x, and then minus or negative 13. So for each of these I'm going to go ahead and multiply. 1/5 times 20y. Well, I can go ahead and multiply them as fractions, or I can just remember that when I've got a fraction like that, 1/5 is the same as dividing by 5. You know, 20 divided by 5 is going to give me 4y. Next one, I've got a positive times a negative, so I've got a negative there. Negative 4x times 1/5. Well, that's just going to be top with the top and bottom with the bottom. 1/5 times 4 over 1. So that'll give me 4/5 x. Positive times a negative is a negative. And this one's just like the other one, top with the top and bottom with the bottom. So I'm going to end up with 13 over 5, or 13/5. So therefore, this makes my answer 4y minus 4/5 x. That does not look like a 5, does it? I need to fix that. Sometimes these styluses always give us a hard time. And then minus 13/5. Okay. Next. Oh, again, same process. I've got, I'm going to give myself some boxes to use here. This time I only have 2 terms. It doesn't really matter, I just match the number of boxes to the number of terms. 8 goes on the outside. Up top I've got negative x and negative 1/2. Okay, 8 times negative x, well that of course is going to be negative 8x. And then 8 times negative 1/2, well it's basically asking us what's 1/2 of 8, and that of course is 4. So my answer here is negative 8x minus 4. Next one. I'm back to having 3 terms. So I'm going to have 1, 2, 3 terms. Negative 8 goes on the outside. Each of the terms sit on top. So I've got negative x, negative 3/4 y, and positive 7/2. Okay, so now I've got negative 8 times negative x, and negative times negative is a positive, and 8 times x is 8x. Negative 3/4 times y. Well, I suppose you might need to see this, so I'm just going to make sure that we can see this. Negative 8 is going to end up over 1 times negative 3/4, right? Top with the top, bottom with the bottom. That's going to give us 24, and it is in fact a positive 24, because negative times a negative gives us a positive. 24 over 4. I know that's going to reduce to 6. And like we said, it is a positive. I didn't include the y when I did that, so I can't forget it there. Then I've got the other one. Also, if it's easier to see it out, negative 8 over 1 times 7/2. Negative 8 times 7 is negative 56. 1 times 2 is 2. So this is basically asking me to find half of 56. Well, I know half of 50 is 25, and half of 6 is 3. So that's going to give me a negative 28. Remember, negative, because positive times negative is a negative. Half of 56 is 28. So my answer for this one is going to be negative, negative 8x plus 6y minus 28. Okay. Kieran wrote the expression x minus 10 for this number puzzle. Pick a number, add negative 2, and multiply by 5. Lynn thinks Kieran made a mistake. How can she convince Kieran he made a mistake? Well, this is a great place to use one of those flowcharts that I talked about, because we know in this one, what do we start with? We start with picking a number. That means it can be anything. So I'm going to make my flowchart start with an x. And then what happens to it? Add negative 2. So my action arrow would be to add negative 2. Put that in parentheses to make it clear to look at. And therefore, that's going to give me x plus negative 2. And then my next action arrow says to multiply that by 5, or times 5, times 5. Okay, so that means I take this entire thing and put it on in the parentheses and multiply that times 5. So 5 times x plus negative 2. So this definitely does not look like Kieran's x minus 10, right? The other thing that we can do, if we wanted to, is to, instead of proving it this way, which I think is really the most efficient, but the other thing we can do is substitute in a number. So what I mean by that is, let's say we want x to equal 1, okay? So in this one, we've got x minus 10. 1 minus 10. Well, if I've got $1 and I spend 10, that of course is going to leave me with negative $9. I'm going to continue to keep x equal to 1, but I'm going to use the number puzzle. So it says pick a number. In this case, I'm picking 1. Add negative 2. So I'm going to do plus negative 2. So 1 plus negative 2, signs are different, find the difference. So it's going to give me negative 1, right? And then multiply that answer by 5. So I'm going to have negative 1 times 5. I know 1 times 5 is 5. The negative times the positive is always a negative. And as you can see, these are not the same. So down here, when we substitute in, we saw that those results were not the same, and clearly these expressions are also not the same. You wouldn't have had to do both of these, but you definitely should have used one of these two approaches. And even if you've chosen to assign a value to x, it didn't have to be 1. And then, now, because we use the flowchart, we already have the correct expression for this number puzzle, and it's right here. So the correct expression for this number puzzle would be 5 times the quantity of x plus negative 2. And some of you probably put that negative 2 in parentheses, and that's okay because you can have two sets of parentheses. And there you go.